for this, we're going to try to figure out who has an absolute and comparative advantage. So I have a 10-year-old, so we've watched a lot of Phineas and Ferb, so I'm going to use Phineas and Ferb here. So an absolute advantage is something that exists when you are more productive than somebody else. You can just produce more. So let's figure out who has the absolute advantage in carnival rides. Okay, so carnival rides, Phineas can produce 2 in a day, Ferb can produce 3 in a day. Ferb can produce more than Phineas, so Ferb has the absolute advantage in carnival rides. He can produce more. Now let's look at rockets. Ferb can produce 9 rockets in one day. Phineas can only produce 4. So since Ferb can produce more than Phineas, he has the absolute advantage in the production of rockets as well. So if you're just better at something than somebody, you have an absolute advantage. If you can produce more, you have an absolute advantage. But that doesn't necessarily mean that you should produce all of everything. So we use something from David Ricardo. He has a comparative advantage, and it says if you have the lower opportunity cost, then you have a comparative advantage. So when we do opportunity cost, we have to figure that out in terms of a ratio. Okay? So we have to do it for both people. So let's talk about carnival rides. So for Phineas, we want to figure out what is the opportunity cost of one carnival ride for Phineas. Okay, so his opportunity cost of one carnival ride. Okay, so what we're going to do is we're going to put that in the form of a ratio. And whatever we're looking for the opportunity cost of goes in the bottom. Okay, so for Phineas, we're going to have the rockets. Okay, he has 4 rockets over 2 carnival rides. Okay, so what we're trying to figure out is how many rockets does he give up in order to produce one carnival ride. So 4 divided by 2 is going to be 2 rockets. So every time that Phineas produces one ride, he gives up the opportunity to produce 2 rockets. Remember, whatever we're looking for the opportunity cost of goes in the bottom of our ratio, or of our fraction. Now let's look at Ferb's. Ferb's opportunity cost of one ride. Okay, we're going to do the same thing. We're going to put it in a ratio. Okay, whatever we were looking for the opportunity cost of goes in the bottom. So for Ferb, the opportunity cost of one ride is going to be 9 rockets over 3 rides. Okay, so 9 divided by 3 is going to be 3 rockets. And we said whoever has the lower opportunity, I put that wrong, the opportunity cost, has the comparative advantage. So whoever has the lower opportunity cost has the comparative advantage and should produce that good. So Phineas, his opportunity cost of one ride is 2 rockets. Ferb, his opportunity cost of one ride is 3 rockets. 2 is less than 3. So Phineas has the comparative advantage in carnival rides. Okay, because his opportunity cost is lower. Okay, so let's do the same thing for rockets. Let's start with Phineas again. So Phineas's opportunity cost of one rocket. Okay, now we're going to basically do the inverse of that fraction that we did before, because whatever we're looking for the opportunity cost of goes in the bottom. So we're going to have 2 rides over 4 rockets is going to be 1/2 of a ride. So every time that Phineas produces one rocket, he's giving up the opportunity to produce 1/2 of a ride, carnival ride. Let's do the same for Ferb. His opportunity cost of one rocket is going to be 3 rides divided by 9 rockets, which is 1/3 of a ride. And we said whoever has the lower opportunity cost has the comparative advantage and should produce that good. So I know nobody likes fractions, but 1/3 is less than 1/2, so 1/3 is lower. Ferb has the comparative advantage in rockets. So if they were going to have specialization and division of labor, Phineas should focus on producing rockets, Ferb should focus Phineas should produce carnival rides, and Ferb should produce the rockets. Okay, so that's absolute and comparative advantage.